Hello, this is Rick Dorsey, Product Manager with the Oracle Complex Maintenance Repair and Overhaul Solution. Today we're going to discuss the operational Autovisit setup and use. This session will prepare the user by demonstrating how to configure and use the operational visit functionality in cMRO. During the session we're going to highlight any dependencies or interactions between profile options, setup parameters, data integration, and user configured data within cMRO. We will begin by reviewing the automated event creation, also known as the Autovisit, process overview. Customers will integrate their operational flight schedules to the cMRO flight schedule table using a public API. The cMRO flight schedule can then be viewed using the flight schedule UI, where records can actually be edited or created manually. The flight schedule will be an input to the automated maintenance creation event process. Other inputs to the automated maintenance event creation process include visit types, operational parameters, default maintenance requirements, and profile options. The automated event creation process will result in the creation of maintenance events, which are known as visits within cMRO. Changes or updates to a cMRO flight schedule record will be also considered by the automated maintenance event creation process. Existing maintenance events which were created off of the flight schedule will be evaluated. This can result in updates to a maintenance event or even cancellation of a maintenance event. Depending on the update or cancellation, there may be system notifications generated as well. Once an event has been created, a line maintenance planner or a crew chief will evaluate the maintenance events. They will also review the maintenance forecast and may enrich a maintenance event with additional work. And eventually the maintenance event will be released to the line maintenance technician for completion. Let's now review the cMRO flight schedule that is contained in the cMRO unit schedule table. As mentioned, Oracle provides an API for loading the flight schedule into the cMRO table. Flight records can be created, updated, or canceled through the API. Maintenance events, or what's known as visits, can also then be created or updated through the automated process by evaluating these flight records. Some key attributes in this table are the aircraft, also known as the unit configuration, flight number and segment pair, departure station, which is an organization and department setup, arrival station, planned date and time, actual date and time, which will be added after an event has actually occurred, and a flight category, which is an optional setup which allows individual flights to be designated as ETOPS or other attributes. We will now review some additional information about an individual flight record within the cMRO unit schedule table. Flight records may be sequential, that is, they may have a logical preceding or following flight, or they may be considered orphan records for an aircraft. This can occur during the first or last day of a scheduled period or when heavy maintenance is scheduled for an aircraft. This can result in an orphan flight record. Customers control the time period of the schedule to be loaded, therefore we need to do some evaluations in our operational process to look for these orphan records and process them correctly. The concept of a unit downtime is the time between the last arrival and the next scheduled departure of an aircraft. These downtimes can be of infinite length and can cross over days. Unit downtimes are seen as maintenance opportunities for event creation and scheduling. During a unit downtime, a sequential flight is shown here in this example. It contains both an arrival and departing flight, sequentially defined for a period of time for an individual aircraft. In this example, there's a unit downtime of 2 hours. Unit downtimes can also consist of non-sequential flights. That is, a flight schedule contains an arrival or a departure flight with a break in a sequential sequence for an aircraft. This can result in an orphan flight record. That is, it's difficult to determine if there's a flight before or after an arriving or departing flight. Therefore, a unit downtime contains infinite hours. We will now view the flight schedule in the flight schedule UI in cMRO, as well as to view the unit downtimes, both sequential and non-sequential flights, that are located in the Search Unit Downtimes UI of the Aircraft Maintenance Planning Workbench. To search for flight schedules, we'll begin by logging into the system. We will then go into the complex cMRO commercial airline superuser profile for this example, to the planning module, unit maintenance plan, flight schedules UI. Within the flight schedules UI, we can search for an individual unit, as well as a date range. We will then see the individual flight records that have been interfaced through the Flight Schedule API. For this particular aircraft, you will see that there's 3 flights on August 5th, 3 flights on August 6th, and a flight on August 7th. These represent individual flight segments. Customers can also drill into the individual flight records to view additional information about the record. If a customer is using the Flight Schedule API, they will most likely restrict access to this particular view and update functionality. We will now navigate to the Planning Workbench, Aircraft Maintenance Planning UI, to view these flight schedules in the context of a unit downtimes view. Within the Planning Workbench, we can go to the Unit Downtime section, search for a particular unit and a time frame. The results table will show the flight schedule in a unit downtimes view. That is, each unit downtime row will represent an arrival flight, a downtime, and a departure flight. The details section will show any visits that have been created during this downtime. And remember, both pre-flight, post-flight, and downtime visits are supported during a unit's downtime period. There are no visits created for this downtime for this aircraft. Within the results records of unit downtimes for this unit and time frame, we will see both sequential flights, which contain an arrival and departure flight with a logical downtime, as well as a non-sequential flight. In this case, we have a flight arrival with an infinite downtime. This can occur at the beginning or the end of a scheduling period, and can also occur when an aircraft is coming in for heavy maintenance. We will now review the operational Autovisit transit visit types, which are an important input parameter to the automated maintenance event creation process. Transit flag visit types are used by the Autovisit process for creating different types of visits based on the operational parameter rows. The visit type definitions provide a work scope framework utilizing stage and duration parameters. It's also important to note that these visit types are used for both line and heavy maintenance. Visit types may be set up for pre, post, and downtime visits by the master configuration. An example may be a visit type of B777 pre-flight, which contains 1 stage and has a 1-hour minimum duration. You may have an accompanying post-flight visit. You may also have a transit visit, which has a single stage and a 2-hour duration, or you may have a more complex RON or remain overnight visit, which could have 3 stages and could be 6 hours of the minimum duration. Each of these is important in evaluating the operational parameter rows. We will now review the visit type setup within cMRO to get a better understanding. We will begin by logging into the system and navigating to the administrative section of cMRO. So we'll log into the same superuser, to the administration module, to the visit types UI. Visit types are set up with a one-to-one relationship to a master configuration. However, a master configuration can have one or many visit types. Visit types can also be flagged as transit visit or component visit types. Component visits are very specific to the component maintenance process and won't be discussed in this presentation. If we search by transit visit types for our master configuration, we will see that we've got our 3 visit types already set up: the pre-flight, the RON, and the transit check. If we drill into the transit check, we can view additional details. We can see a duration of the visit type, which is the minimum duration as defined by the stage setup. Within the details, we have the different stages and the stage associations. So if we drill into the details, we can see that stage 20, which is servicing, always is executed or is sequentially executed after the inspection or stage 10, We can also have rules which allow them to be worked in parallel. Within each stage, there's also stage types. This allows for further definitions of stage types, which can be used in the routes to automatically place certain work in different stages within the visit. For our pre-flight example, it's a much simpler visit type. It only has a half-hour single stage for pre-flight inspection. To create a new visit type, we'll click on the Create button, and we'll have to select a predefined LOV, a visit type, and we're going to set up a post-flight. The master configuration will be our same master configuration, and we'll flag this as being a transit visit type, and click Apply. As you can see, the duration is currently 0 hours as we don't have any stages defined. So in our example, we're going to build a simple stage, name it a unique stage name, set a duration, a decimal duration, not a time duration, and click Apply. And both the stage will be created and the minimum duration of the visit will be updated. We can then go set unique stage types. And this will help with the staging of work within the visit. So we're going to pick a simple inspection stage type here and add that to the stage definition. And once you're done, we can exit back to the main screen. And you can see that I have my new visit type in a draft status. We can continue to edit it using the Update button, or we can click the Complete button, and you can see that our post-flight visit type has been created and saved. An additional input to the operational Autovisit process is the ability to utilize the default maintenance requirements. This provides the ability to automatically add maintenance task cards to a visit during the creation process. These maintenance requirements are unplanned and are added as additional work per the work scope. They're controlled by validating the associated visit types in any unplanned maintenance requirement definition. The maintenance requirement still respects effectivity definitions, and this just allows an easy way for the planner to automatically create visits with these maintenance task cards. It ensures a consistent work package creation while supporting both line and heavy maintenance visits. We will now review the setup of a maintenance requirement visit type to show that in an unplanned maintenance requirement, these can be automatically added to a visit creation. We will begin by logging into the system, and then we will navigate to the engineering module, Fleet Maintenance Program Overview. Here we will search for the maintenance requirement that we want to have added to a visit. We'll drill into the maintenance requirement definition. The visits types link here on the left-hand side will allow us to associate one or more visit types for each unplanned MR. When a visit is created of this type, the system will automatically look for any associated maintenance requirements that meet the effectivity definition and have a matching visit type. And then the system will automatically add these during the creation of the visit. To add additional visit types, we'd have to create a revision to the maintenance requirement, and then we could add additional rows. And click Apply to save. Now a second visit type has been added pre-flight, and this maintenance requirement will automatically be added to the visit when it's created. This is extremely useful functionality and cuts down on planner time required to add generic task cards to maintenance visits. The Autovisit process also leverages two profile options. These are used to reduce complexity and to maintain performance during the processing of the flight records. The first profile option covers flight visit updates. It controls if visits are updated or canceled based off small changes to a flight record's arrival and departure time. An example may be that a flight has changed by 5 minutes, 10 minutes, or perhaps 1 hour. To To reduce on the constant number of changes that could be introduced through a small flight schedule variation during a scheduling period of, let's say, today or the next day, we've added in this control profile, which will allow a small buffer in which the flight visits do not need to be updated if the flight record has changed up to this maximum value. An example may be 15 minutes. So if flight records are not changed for a time period greater than 15 minutes from its original time, then we will not make any associated changes to the visits. This is just to reduce processing time and to reduce complexity. The second profile option controls the number of days into the future in which the flight schedule will be evaluated. Some customers may choose to load a 30, 60, 90, or even longer schedule to help in long-term maintenance planning. However, for Autovisit planning, this can create some complexities as that schedule could be constantly updated. Most customers work off a 3 to 7 day flight schedule, with 1 to 3 days being the most accurate information, as aircraft pairings and flight line assignments can vary and get updated each and every hour. Therefore, this flight update window controls how many days in the future we will look at the flight schedule. Now we'll talk about the operational parameters setup that feed into the automated maintenance event creation process and provide guidance for evaluating a new or updated flight record. This process is executed through a concurrent program request, and we also have a manual way to run it as well. The program considers preceding and succeeding flight records, if applicable. It also considers existing visits attached to these flight records, the duration of the downtime period, and other key parameters. These key parameters include the organization and department, the master configuration of the aircraft, any flight category information from the flight record, such as ETOPS, the duration of the downtime, the minimum ground time required to create a visit during that ground time, the visit type, and this is the visit type to be created, and if an alternate department is required during the creation of the visit. We will now review the operational parameters setup within the cMRO system. We will begin by logging in the system, and then we will navigate to the planning module to view the operational parameters setup for the Autovisit processing. So within the super user responsibility within the planning module, there is an Autovisit planning setup, operational visit auto create UI. This UI is set up in the context of an arrival organization or departure organization, a master configuration, and a visit type. We're going to begin by searching for our particular aircraft by master configuration. We will search by the master configuration of our test aircraft, and we will search for the results rows. In this example, we've got 4 operational parameter rows. And you'll see from the results rows that they're sorted by the organization and department, the applicable master configuration, and the ground time evaluation and creation parameters. So each parameter row looks at the ground time, which is the time between the flight arrival and the flight departure, and it looks at the duration. So in this case, we've set up parameters that are from 2 hours to 3 hours and 59 minutes. If we found a ground time that has been between those values, then we will create a downtime visit of a visit type called transit check. And the visit is scheduled at being up to 2 hours long. We also have the ability in the Create For drop-down to create both arrival visits, which are your post-flights, departure visits, which are your pre-flights, as well as the full downtime visit. We also have the Enable checkbox, which allows the user to quickly enable or disable a row without deleting it. To speed in the creation and editing of parameter rows, we also have a duplicate or copy button, and we do have the ability to permanently remove or delete the row. You'll see for the second parameter row for JFK line maintenance, we have another evaluation period of 4 hours to 12 hours, and we'll be using a different visit type of RON, which is remain overnight, and it creates a visit which has at least 4 hours of estimated duration on it. So even though a downtime may be 12 hours long, we'll create a visit that spans the complete downtime, but is at least 4 hours long. So this allows us some flexibility in defining a minimum work scope for that visit, but leaving it flexible so that same visit can be used over a time span of a from and to value. Similar setup rows are set up for San Francisco as well, both a transit check and an RON. If the user wanted to go and create another one for Dallas using these same two parameter rows, we can go and use the duplicate button. We can then go in and change the organization and department. And we can quickly save that row. We can then go and copy the Dallas and create a transit check as well by changing the parameter rows for the ground time evaluation and changing the visit type. We can also quickly enable or disable by unchecking or checking the rows. We can also create operational parameter rows for pre-flight and post-flight visits. We can either copy an existing row and modify it, or we can create a new row. In this example, we'll just duplicate an existing row and change the attributes. So we're going to create a departure or a pre-flight downtime. And you can see that the from and to hours in the ground time are no longer required for evaluation. This means if a downtime is less than 2 hours, a pre-flight visit will be created. So we can select the appropriate visit type, which is pre-flight, and we can save the record. And the pre-flight operational parameter row will be created. So in this example, we have 3 parameter rows for Dallas. So therefore, before a flight, we create a 30-minute visit of visit type pre-flight. Then if the next time that the aircraft comes in, if it's there in Dallas from 2 hours to 3 hours and 59 minutes between flights, a transit check will be created. If it arrives back in Dallas and there's a downtime between 4 and 12 hours, an RON check is created. If it's greater than 12 hours and 1 minute or greater, no checks will be created. So this provides some control over both the time and the visit type being created. We will now review the operational auto-visit process from a flight record evaluation perspective. As noted, the cMRO flight schedule records are evaluated by the automated maintenance event creation process. Operational parameters are an input to this process, and they provide guidance for evaluating the flight schedule records, their associated downtimes, while also determining if maintenance events should be created or not, or potentially edited. The auto-visit process may create a pre-flight or post-flight visit, or a downtime transit visit, which spans the complete unit downtime. Existing visits associated to flight records will be considered. Updates to flight schedules may result in the creation of new visits, or for existing visits, cancellation or disconnection. Disconnection is a term used for the flight record and the visit record will become disconnected and won't be paired together in the unit downtimes UI. During the operational auto-visit process, maintenance events or visits will be created. There are 3 different types of visits that will be created during a unit's downtime. Depending on the type of visit created, they can be associated to the arrival or the departure flight. We'll begin by describing the first type of visit, which is the post-flight visit. It's associated to an arrival flight and typically is for a duration that is less than a unit downtime. The next is a pre-flight visit. It's associated to a departure flight record and is typically less than unit downtime as well. The third type is a downtime or transit visit that expands the complete downtime between the arrival flight and the next departure flight. Please note that post and pre-flight visits can but should not overlap. Post-flight and pre-flight visits can be used for short downtimes or longer downtimes where a downtime visit doesn't make sense. We will now review the processing of flight records for maintenance events that occur over time with the flight schedule. So for the current day, an arrival flight comes in, and let's say it's the last flight of the night, with the red line being the date indicator for 2400 hours, and there will be a unit downtime of some unknown length. The system will look forward for the next flight that's in the flight schedule. In this case, it's a departing flight that's the next day. It'll evaluate the unit downtime to determine whether or not the operational parameters are set up and configured correctly to create a post-flight, pre-flight, or downtime visit. It'll then go to the next flight record, which is the arrival flight for the next departing flight, review its unit downtime, and so on. and it will continue going into the future, working sequentially. And this process will repeat for the flight schedule for each day. Some customers may choose to only set up simple auto-visit creation, such as overnight visits. In this case, they would create downtime visits, which would potentially cross over the date line, but more importantly, they would be for a long period of time and would extend from an arrival to a departure flight with a single visit. The system will then continue to evaluate the flight records into the future, and will use the operational parameters to determine if visits should be created during the next downtimes. A customer may choose to not create any pre-flight and post-flight or downtime visits during these shorter downtimes. It may wait till an aircraft arrives at a maintenance visit or has a sufficient downtime in which to create a visit. And then the process will continue to repeat itself into the future until all the flight records have been evaluated. A customer may also choose to do more detailed planning, such as transit and overnight checks. In this case, they would set up the creation parameters to create post-flight and pre-flight visits during the flight schedule, and during some predetermined operational parameter rows, they may create a downtime visit for longer downtimes, and the process would continue to repeat itself. This gives the customers a lot of flexibility in creating either no visits, only overnight visits, or a combination of transit and overnight visits. Here we will walk the processing flow for evaluating flight schedule records while creating operational visits. It begins by a flight record being added. This is a new flight record. The flight record is then analyzed by the concurrent program. Operational parameters are evaluated against this flight record, including the preceding and succeeding flight records. Any existing visits are evaluated and could possibly be canceled. And finally, new visits are created. Now we'll discuss in depth a little more about the concurrent program. This can be set up to run periodically in coordination with the flight schedule table updates. Ideally, a customer would run a batch of flight schedule updates and then run the Autovisit program for both the creation and the update of flight records. This will support new events being created, while existing visits could be updated or canceled, as shown in the process flows. After these processes are complete, there could be some exception notifications generated for disconnected flights, that is, visits and flights have been disconnected and are no longer associated with the flight record. Any downtime discrepancies for existing visits where a ground time now is much less than an anticipated visit downtime requirement. If visits have been canceled that contain planned requirements, and if there's any other visit exceptions. We will now run through a demonstration of reviewing the unit downtimes where there are no visits created. We will then run the concurrent program, view the output log, and then return to the unit downtimes to see the impact of the visits that were created, per the operational parameters. We will begin by logging into the system, and then we'll navigate over to the planning module, to the planning workbench UI. We'll then use the unit downtimes functionality at the bottom of the page, and we'll search for our unit. We'll then see that there's flight schedules created and associated unit downtimes, including an orphan flight record. We can then view if there's been any visits created by clicking the Show All Details button. We'll notice that there's been no visits created for any of these downtimes. We can then hide the details. We can now navigate over to the Autovisit Planning UI to view the operational parameters set up. From here, we can also run the two processes that are available. One is the Run Create Operational Visits, and the other is the Run Update Operational Visits process. We can select whatever process we wish to run and click the Go button when we're ready. This will launch the concurrent program for all flight records which have been created in the system. The user will receive a concurrent request number that they can track and confirm its completion. From within the Oracle Forums, the user can go and view all of their requests that have been run, and they can check up on this concurrent program. In our example, we ran the process operational visits program. It has completed and its status was normal. We can then view the log, and we can see that 6 downtime visits were created, visit numbers 272 to 277. We can now go and view these in the Unit Downtimes UI. We can now return to the Planning Workbench, to the Unit Downtimes UI, and search for our unit again. We can then see that between each of the downtimes, a transit check or downtime visit has been created. And you can see that in this example, 7 visits have been created. The operational parameters were set up to first create a downtime visit as taking precedence over a pre-flight or post-flight visit, giving the duration of the downtime. We will also see that for the orphan record, a downtime visit was not created because the operational parameter row could not validate an infinite amount of downtime for a ground time between flights. However, had the user set up a post-flight in an operational parameters, a post-flight visit could be created after the arrival of this visit type. We will now review the Autovisit process for the Update Operational Visits concurrent program. This will be launched after a flight schedule has been updated. So flight schedule records either get canceled or updated, or of course new records can be created. The flight records will be analyzed for impact on current visits, as well as the creation of new visits. The operational parameters will be evaluated against these flight schedules. Visits will be canceled or created, and visits could be updated. This, of course, will work with the profile options that we've set and have described earlier in this presentation. We're now going to review further the evaluation of unit flight schedule records and the impact on existing visits or possibly the creation of new visits. When a flight record gets updated, in this case a departure flight, the system has to look both before the departure flight for any downtime or pre-flight visits. It also has to look at the next flight record to see if there's any impact on its flight arrival and any downtime or post-flight visits as well. In our example here, both the pre-flight and post-flight visits could be impacted on both of these flight segments. Let's look at this a little bit further. So during a unit downtime, we have both the post-flight and pre-flight visit created, and the unit downtime is currently 1 hour and 30 minutes. If a flight schedule change occurs and a unit downtime has now been increased to 2 hours, we'll rerun the process in the update mode and it will evaluate the operational parameters. One example may be just to keep the remaining visits in their places, and now you'll just have a bigger gap between the post-flight and pre-flight visit, which is perfectly acceptable. Another option may be to cancel those visits and create a downtime visit. In this example, we have an operational parameter row which has a minimum required downtime of 2 hours. So therefore, the pre-flight and post-flight visits would be combined into one new downtime visit. Another example is if a unit downtime actually shrinks. In this example, the unit downtime was 2 hours and a downtime visit was created. However, after a schedule change, the unit downtime shrank from 2 hours to 1 hour and 30 minutes. In this case, the downtime visit could have been canceled and a post-flight and pre-flight visit were created instead. The last example is if the same flight schedule was changed from 2 hours to 1 hour and 30 minutes, an existing downtime visit A may be replaced with downtime visit B. And downtime visit A could get canceled or disconnected. An example of the visit getting canceled would be based on some validations that there's no planned MRs in the visit. If there's planned maintenance requirements in a visit, the visit will be disconnected and a notification will be sent to the user. That way the planner can make an informed decision about how to replan these required maintenance attributes. The operational Autovisit process provides the following benefits to our customers. First, it provides a simple, straightforward process for automatically creating transit maintenance visits based on a customer's flight schedule. Secondly, there's flexible parameter setups which allow customers to create either basic or advanced evaluation logic of the flight schedule records and their accompanying transit visits. This also provides for a basis for an exception-based maintenance planning process. And lastly, this will make life much easier both on the line maintenance planners, supervisors, and the maintenance technicians. For further information about cMRO, we invite you to visit our product website. You can also feel free to email me at rick.dorsey@oracle.com for additional questions about the Autovisit process. This concludes our presentation on the Autovisit process for the operational Autovisits.